So picture this. You pull out your phone to order dinner. You're tapping through a restaurant menu, picking your items, you see the driver on a little map, and then you pay, all with a single click. It feels like it's all happening in one single, seamless app, right? Well, behind that screen, dozens of totally separate systems are all talking to each other, like at lightning speed. And the invisible glue holding it all together? That's the API.
No, really, just stop and think about it for a second. When you book a cab, your app has to talk to a mapping service like Google Maps, a payment system like Stripe, a notification service to send you texts, and a location service that's tracking thousands of drivers in real time. These are all completely different pieces of software, probably built by different teams, maybe even by totally different companies. So how on earth do they coordinate so perfectly? Well, the answer is the Application Programming Interface, or API. And to get how it pulls this magic trick off, we got to break down what an API really is.
All right, the first and probably the most important thing to get into your head is this. An API isn't just a chunk of code or some random URL. It's much, much better to think of it as a formal agreement. You know, like a contract between two different computer programs that spells out the exact rules for how they're going to talk to each other. The key phrase on this slide is strict contract. I mean, this thing specifies everything, what the data has to look like, the security rules, the exact error messages you'll get back, and what every single possible action means. It completely removes any guesswork, making sure that when two systems communicate, they understand each other perfectly. There's no room for misinterpretation. So, at its very core, every single API interaction has these three main players. First, you've got the caller, or the client. That's your phone app, and it wants something. Then you have the provider, or the server, which has the data or the function that the client wants. And sitting right in the middle is the API. It's the interface that lays out all the rules of engagement. The beautiful part is your app doesn't need to know how the server does its job. It just needs to know how to speak the language defined in that API contract.
Okay, so we've got this idea of a contract, but how does that actually translate into a real request flying across the internet? We're about to pop the hood and break down what an API call actually looks like. It might seem a little technical at first, but trust me, it's actually pretty logical once you see the pieces.
Think of an API request, like a package of information that your phone mails to a server. And even though it travels as this one single unit, it's really made up of 4 distinct parts. So let's break down exactly what goes inside that package, piece by piece.
First up, we have the method. This is basically the verb of the request. It tells the server what you want to do, your intent. For example, a post method means, hey, I want to create something new. Other common ones are get for reading data, put for replacing it completely, and delete for, well, deleting it. Pretty simple, right?
Next is the URL. Now, if the method was the verb, then the URL is the noun. It tells the server which thing you want to perform the action on. For instance, a URL with /orders in the path tells the server you want to do something with the collection of orders. You can even add query parameters to filter things down, like asking for orders that belong only to a specific user.
The third part is the headers. The best way to think about this is like the administrative paperwork for your request. It's got all the critical metadata, like an authorization header to prove who you are, or a content type header to tell the server what format your data is in, like whether it's JSON or something else.
And finally, we have the body. This is the good stuff, the actual data you're sending over. If you were sending that post request to create a new order, this is where you'd put the details, like the ID of the product and how many you want. Now, if you were just doing a GET request to read data, the body would usually be empty, because you're not sending any new information.
So, the client has put its request together, all 4 parts, and sent it on its way. But hey, communication is a two-way street. The server also has to follow a really strict set of rules when it replies, so that the client knows exactly what happened, whether it worked or if something went wrong.
And this is where HTTP status codes come into play. These little numbers are universal shorthand. Just think of them like traffic lights. A code in the 200s, that's a green light, success, everything worked. A 400-level code means the client messed up somehow. Maybe you asked for something that doesn't exist. And a 500-level code, that means something broke on the server's end. It's not you, it's them. Okay, now here's a really, really important idea in modern APIs. It's the concept of being stateless. In a stateless system, the server basically has amnesia. Every single request you send it has to contain all the information needed to process it from scratch. The server doesn't remember a thing from your last request. Now, that might sound inefficient, but it's actually what makes it possible to scale a system to millions of users, which is why almost all modern web APIs are designed this way.
That simple model of a client and a server is awesome for getting the basics down. But a real-world, global service like a Spotify or a Netflix, well, it looks a whole lot more complicated. So let's trace the journey of a request in a real, live production system.
A single request from your phone doesn't just go straight to one big server. Oh no. First, it's probably going to hit a CDN, a content delivery network, which keeps a copy of data physically close to you so it's faster. From there, it goes to a load balancer. Think of it as a traffic cop that makes sure no single server gets overwhelmed. After that, it hits an API gateway, which is like a security guard, checking your credentials before it routes your request to the right microservice, a tiny, specialized program that does just one job, like handling orders. And that microservice is what finally talks to the database. Phew! Now, in these super complex systems, not every task can give you an answer right away. I mean, if you upload a giant video to be processed, you don't want your app to just freeze and wait, right? That's the huge difference between synchronous and asynchronous communication. Synchronous is like a phone call. You ask a question and you wait on the line for the answer. It's blocking. Asynchronous is more like sending an email. You send it off, you go do other things, and you get a notification when the result is ready. Both are totally essential for building modern apps.
Wow, we've covered a lot of ground here, from the tiny pieces of a single request all the way up to the architecture of a massive global system. So let's zoom out one last time and really lock in the most important high-level truths about APIs.
If you take away anything from all this, let it be these key points. First, and say it with me, APIs are contracts, not just code. Second, you always have to assume the network is slow and might fail. That's why system design is so critical. Third, the secret to building huge, scalable systems is using APIs to decouple services so they can change and grow independently. And finally, just accept that real-world software is messy, it's distributed, and a lot of it is asynchronous. And that brings us to our final and maybe most powerful mental model. APIs aren't just the plumbing or the messengers. They are the nervous system that connects countless individual programs, allowing them to act like one huge, coordinated organism. So the next time you tap a button on your phone, just take a second to remember that invisible nervous system that's firing behind the scenes, that complex global conversation, all orchestrated by these powerful little contracts we call APIs. Now you have to ask yourself, what part of our modern world isn't run by APIs?